Okay, let me introduce to you a function of 3 variables. Okay, so we've just done a bunch of functions of 2 variables, right?
Mm-hmm.
And what were our tools for exploring those? Yeah, we did slices, right? And they were f of x and y's. So they got, how many dimensions did we need to draw pictures? 3. Okay, so if these are functions of 3 variables, these are going to look like f of x, y, and z is whatever it is, right?
Yeah. So is this making 4-dimensional objects?
Yeah, so these are the graphs of these, right, are going to be 4-dimensional. However, you know some things like this. Okay? A nice example for something like this would be temperature at x, y, and h. Right? So here we're at an x and a y, right? But if I go another 1,000 feet up in the air, right, the temperature is going to be different. Yeah? Okay. So, well, here's 4 dimensions, right? But I can envision this, right? There's a x and a y, that's a position on the ground, then there's a height, and then associated to that spot, there's a temperature.
We just don't really use 4 spatial dimensions.
Yeah.
Because
Yeah, because I don't know what the other spatial dimension might be. Yeah, but I can have 4 physical dimensions, right? They're not necessarily spatial, but physical certainly. You guys see that? We could even do like, never mind. There is a good reason that more dimensions might be needed for something, but let's skip it for right now. Let me just give you a tool to explore. So let's go back to our f of x, y, and z, and just say that we had x squared plus y squared plus z squared. I want to be able to draw something for this, right? So in our functions of 2 variables, we pick some level curves, right? Okay. So in 2 variables, I needed 2 dimensions to draw level curves. So for 3 variables, I'm going to need 3 dimensions to draw level curves.
3-dimensional slices.
Yeah, so I'm going to take. Yeah, so I'm going to take a 4-dimensional object, I'm going to slice through it, and I'm going to get a 3-dimensional object, right? Okay, so how does that work? What's your first slice you want to take of this thing?
set it equal to 0.
Yeah, set it equal to 0, right? Yeah. First slice should always be 0. So when x squared plus y squared plus z squared is 0, what do you got?
A 0 radius sphere.
A 0 radius sphere, right? So that's easy to draw in here. That's a point at 0, right? Yeah. Okay, so that's my level curve for f is 0. Okay, what's your next level curve you want to take? Probably 1. That seems reasonable. So you got x squared plus y squared plus z squared is 1. Maybe for emphasis, 1 squared. What do you get out of that? Sphere of radius 1. Okay, so there's my f equals 1 level curve, right? See that? Okay. What's your next level curve you want to take?
2.
No. Don't be ridiculous.
4.
4. 4 is the level curve you want to take. Why is 4 the level curve you want to take?
2 squared.
Okay, it's 2 squared, right?
Oh, okay.
So I know how to draw that one. If I got root 2, right, squared, then I'd have to try to figure out exactly how to graph that on here. But now I can just go the same distance I went out before. Oh, and this is where my drawing is going to collapse.
Useful there.
Oh, I had it really well until there.
It's a reoccurring trend.
Okay, cool. So the black then is my Z is,
Oh, yeah.
Or,
yeah, that was the Z is 4 level curve, right?
That's great.
Oh, that's kind of dork.
That's weird.
My
It
bad.
got dropped.
All right, so what about the, what are other interesting level curves? You guys had one a second ago.
9.
Suggested some, okay, so 9's another easy one to draw, right? What's that gonna look like?
It's just a bigger sphere.
Yeah, bigger sphere, right?
Even bigger.
So what am I envisioning? Well, maybe I'm envisioning as I walk out from the origin in any particular direction, right? That the temperature goes up or something, right?
So like the sun is the center. That'd be the opposite.
Yeah, but something like that. What are other level curves that I haven't drawn that might be interesting?
The C. No.
We could take some slices in other directions, right?
Yeah.
But then I'd need a W axis to draw them. You guys see that? We could try that. We'd get a paraboloid in all the other directions. And I have trouble figuring out how to put 3 paraboloids and some spheres together, right? You guys all see that? It's a little bit like a higher dimensional paraboloid, right? You guys see that? To get a paraboloid, right, I put 2 parabolas together and a circle. So probably if I put 3 parabolas or paraboloids and a circle together in 4 dimensions, I probably get whatever the heck a 4-dimensional paraboloid looks like.
So maybe -1.
Yeah, but I might consider negative level curves. Do those appear on here?
It's the same.
No, right? That slice doesn't hit my functions graph at all. You guys see that?
Will this show up in the imaginary realm in any way?
Yeah, so anytime you want to talk about a complex function, that's a function from, so a complex function would be a function from the complex numbers to the complex numbers, right? This is 2D to 2D. So you're gonna have to do some 4-dimensional thinking to get from one to the other. Your graphs don't live in the 4-dimensional space that this thing is though, right? This is 3 inputs crossed with 1 response, right? That's 2 inputs crossed with 2 responses. You guys see that? Your output here is 1-dimensional, your output there is 2. But yeah, that kind of idea comes up. You end up drawing in complex numbers something like this a lot. And then you'll say, okay, like this little piece here ends up wrapped around there or something. Questions, thanks?